Okay, a little bit more about how circles work together and form motion and some things that happen. This time we're going to look at sort of systems of circles, how more than one circle will work together, and how they interact with each other, and what's the same and what's different about them. We'll look at it with gears. This is a wheel and axle system. These are a wheel and axle system. And obviously this is a pulley where you've got two different discs, but they're connected by a rope, and one is spinning the other. All right, systems will have the same linear speed, when they are wrapped by the same belt or they are gears, okay? So systems will have the same linear speed when they are wrapped by the same belt, like they are in the pulley system, or they are gears and their teeth interlock. So a pulley system is something like this, where you've got two discs wrapped by the same belt. Gears are those things where you have teeth. So I have a gear here, and then I have a gear here. This is really sloppy, you know that. But the teeth interlocked and those two circles spin. That's a gear system. And then you will have the same linear speed. Okay, you'll have the same angular speed when discs rotate around the center, around the same center. So when they spin around the same axle or the same center, then they will have the same angular speed because they will be spinning at the same time, making the same number of revolutions in a certain amount of time. And I should put the word same here. All right, so if I look at this, what I know is that disc A and disc B are spinning around the same center. Okay, they're spinning around the same center, so they will have the same angular speed. Disc B and disc C are wrapped by the same belt, so they will have the same linear speed. Disc A and disc D, and I didn't have a way to draw this on the computer, but you're going to think of these as the teeth right here. And so they are gears, and so because they are gears, they will also have the same linear speed. So we're going to use that in order to find as much information out as we can about the linear speed and angular speed for all four of these discs. Okay? So I'm going to flip back and forth a little bit, but the only thing I gave you really that gives you any kind of speed is this right here. So for disc B's speed, it is 20 revolutions per minute, and so I gave it to you in revolutions per time, and revolutions per time is your angular speed. Okay, and remember that your angular speed is your W, and your linear speed is your V. So what I just gave you was the angular speed for roller B. Okay, so angular speed for roller B would be in 20 revolutions per minute. When you report angular speed or when you use it in the other formula, it has to be given to you in radians. And so you need to remember that one revolution or one trip around the circle is 2 pi radians. The revolution needs to be on the bottom so that they will cancel with each other like that. Okay, and when I multiply that out, I will get 40 pi radians per minute. All right. I can use that then to find my linear speed for roller B. And my linear speed, again, I will find by doing V equals R times W. So if you go back here and I look at disc B, the radius for disc B is 2 centimeters right here. And so I will use that to find the linear speed. So the linear speed will be my radius, which is 2 centimeters, times my angular speed, which is 40 pi radians per minute. And I can multiply that out, obviously, to get 80 pi. You're talking angular speed, so your radians are that magical unit that will disappear, and your angular speed then will be in centimeters per minute. Okay? You can just use whatever units are natural in the problem unless I tell you otherwise. Sometimes you're going to need to convert them to a unit that I ask for, but unless I ask for that unit, you can just use it use the units that are natural in the problem. All right, so that completes roller B. That's fabulous, disc B. Now we need to move on to a different disc. So I need to think about what I know. Okay? What I know is that disc A and disc B spin around the same center. So if I look at A and B, they spin around the same center, so their angular speeds will be the same. So their angular speed for this one would be same as B because it has the same axle. They spin around the same axle. I don't know if axle's EL or LE. We're going this way. Okay? You might prove me wrong. Anyways, they spin on the same axle, and so this will be, again, 40 pi radians per minute. Okay? And then I can do the linear speed for A while I'm at it by doing V equals R times W. Okay? And for disk A, if you look over here, your radius is 4 centimeters. So I will use that for my radius. And we know that our W is 40 pi radians per minute, which I'm just using from that box to the left here. And when I multiply that out, I should get 160 pi centimeters per minute. All right, so now I've got A done and I have B done. Now I need to try and figure out what I can know about C and D. So let's see. Let's go to C next. And I can see that B and C right here, disc B and disc C, are wrapped by the same belt. And because they're wrapped by the same belt, they will have the same linear speed. So B and C will have the same linear speed. So this is going to be the same as B because it is wrapped by a belt. Okay, so I know that this will be 80 pi centimeters per minute. Okay, then over here, again, I know that V equals R times W, which I'm trying to find W in this case. So W is V over R. Okay, so in this case, I will have my V, which is 80 pi centimeters per minute. And if I look at roller C back on the diagram, the radius for roller C is 3 centimeters. So I will have 3 centimeters down here. And so I will have 80 pi over 3. That doesn't reduce. Centimeters will cancel, and you'll need to have something per minute. And again, radians is that magical unit. And also, when you're using it in this formula, it has to be in radians. So 80 pi radians per 80 pi over 3 radians per minute. Now, all we have left is roller D. So I'm going to go back and I'm going to look at the picture and see what I know. And I know that D is connected by teeth here to circle A. So if I look at A and D right here, they're connected by gears, which means they will have the same linear speed. When you have gears, you have the same linear speed. So A and D have the same linear speed because they are gears. And A's linear speed was 160 pi centimeters per minute. And again, I know that W is V over R. And so in this case, my V was 160 pi centimeters per minute. And if you look at the picture, the radius for roller D is 1 centimeter. And you'll divide that out. The centimeters will cancel. And you'll end up with 160 pi something per minute. And again, radians is that magical unit that will appear and disappear. And there you have it. So with when you're looking at systems of circles, gears, pulleys, axles, all that kind of stuff, you just sort of have to look to see what you know. Some things will be the same and see how they're related and go from there. Okay? Hopefully that helps.